In this video, I'm going to talk about some examples involving continuous functions. The first example is this one, f of x is equal to x plus 1 over square root of x. And the second example is f of x is equal to 1 plus e to the power x divided by 1 minus e to the power x. So let's start off with the first one. Let's call this a rational function. It's a rational function because it's a ratio of two functions, right? Division of two functions. Let's call this g of x, which is x plus 1, and the numerator, and h of x, which is square root of x, the denominator. So g of x is equal to x plus 1, and h of x is equal to square root of x. From our knowledge, we know that both of these functions are continuous. This is a polynomial function and this is a square root function. Both of them are continuous. However, in the denominator, the square root function appears. Therefore, we need to make sure that it is non-zero. So this is g of x is continuous. It's a polynomial. It's continuous on the entire number line, right? This is continuous on the entire number line. This, however, is continuous from 0 to positive infinity because we are not dealing with complex numbers, therefore, or complex functions. Therefore, we are going to restrict our x values to 0 or positive. Now, having said that, square root of x, if it is 0, by the way, if x is equal to 0, then square root of x is going to be equal to 0 too. Normally, this wouldn't be a problem if the square root of x were to appear as a numerator. So let's say consider a function called k of x is equal to square root of x over 1 plus x squared. In this case, this appears in the numerator, so it could be 0. However, in our case, it appears in the denominator right here. So it cannot be 0. So we must exclude this 0 for the purpose of this function. Because if x is 0, the denominator is going to end up becoming 0. That means we are going to have division by 0 that is unacceptable, or that makes the function undefined at that particular point. So for our purpose, since square root of x is in the denominator, is going to be from 0 to infinity. Now the numerator is from negative infinity to positive infinity. The denominator is from 0 to infinity. Where do they overlap? That's what we should be looking at. Okay, 0, 1, 2, okay, and keeps going, negative 1, negative 2, and keeps going. Where do they overlap? So let's see. The first one, by the way, is the entire number line, right? But the second one says it has to be where? Starting from 0, right? So, let's use a different color so that you can see it. So from 0, right? Excluding 0, everything to the right. So it's going to be everything to the right. So where do the green and the blue overlap? Right here between 0 and infinity. So your domain for this function is going to be f of x. This domain is going to be from 0 to infinity. And this function, this rational function, is continuous in the entire domain. Now let's go ahead and talk about the second example, which is f of x is equal to 1 plus e to the power x over 1 minus e to the power x. As you know, exponential functions, they are continuous everywhere, okay? And also not only continuous, they are non-zero, okay? They are non-zero. So let's kind of sketch it for you so that you remember exponential function looks like this. E to the power x. Now, again, it's continuous everywhere on the number line. So the numerator, let's call it g of x, and the denominator h of x. Both of these are continuous functions. Continuous function which happens to be exponential functions. We know that ratio of two continuous functions is going to be continuous, except we need to make sure that the denominator doesn't evaluate to 0. So let's find out for what value of x the denominator becomes 0. So let's say we set it equal to 0. The way to find it out, take the denominator expression and set it equal to 0. So this, if I add e to the power x to both sides, e to the power x, I get 1 is equal to e to the power x. Okay. Now to solve for x, I can apply the natural log to both sides, ln, because natural log is the inverse of exponential function. So ln of 1 is equal to ln of e to the power x, but ln of 1 is what? 0. And ln of e to the power x is x times ln of e. But ln of e is just 1, okay? So that gives me 1 times x, which is x, or x is equal to 0. So when x is equal to 0, the denominator will become 0, because look, 1 minus e to the power x is equal to 1 minus e to the power 0. E to the power 0 is 1, so 1 minus 1 is equal to 0. So we are going to have division by 0 where the function will not be defined. Therefore, our region of interest, or rather I should say set of numbers of interest, okay, the region kind of gives the impression of area, or the numbers that we are interested in on the number line, everything on the number line except for the origin. That means x equal to 0. So it becomes what? Everything to the right and everything to the left, excluding the point 0. Now, what is the domain for this function d, which is going to be from negative infinity to 0, exclude the 0, union 0 to positive infinity. I hope that this discussion was helpful. Thank you very much.